Hello everyone, we're going to have a very short lecture about buoyancy. Okay, our objectives for this lab are to learn how to determine the magnitude of the buoyant force on an object and predict which characteristics affect the magnitude of the buoyant force. Probably one of the most important concepts of this lab is going to be density. Density is defined as a mass per unit volume, so it's a mass over a volume. The volume, of course, can be calculated as an area times a height. The area being a cube or a circle times a height. Archimedes' principle is the basis of the ideas for buoyancy. Archimedes' principle states when a body is completely or partially immersed in fluid, the fluid exerts an upward force on the body equal to the weight of the fluid displaced by the body. The upward force that the fluid exerts on the object can be called the buoyant force. We can think of this as acting on the center of mass, just like gravity. And that also explains why if you are ever younger, try to stand on a ball in a swimming pool, and of course it's very, very unstable. It's because it's difficult for that force to be acting right on your center of gravity. Okay, mathematically, Archimedes' principle is the buoyant force equals the mass of the liquid displaced times gravity. Now clearly the volume of the liquid displaced is equal to the volume of the object submerged in the liquid. Then we can show that the explicit relationship between the buoyant force and the volume of the object. So the first part there, rho equals ml over v. So it's the density equals the mass of the liquid divided by the volume. Or you could say that ml equals the density of the liquid times the volume of the liquid displaced. So the density is done in kilograms per meter cubed, and volume, of course, is in meters cubed. So that leaves you, whenever you multiply them together, that just leaves you with kilograms. And of course, that's going to be the same as the density of the object times the volume of the object. So in the end, the buoyant force equals the density of the object times the volume of the object times gravity. Basically, F equals ma, where VL is the volume of the liquid displaced and VO is the volume of the object. Now comes a really fun concept. From our previous equation, we can see that the buoyant force only depends on the volume of the object, not its mass. However, the net force is directly affected by the mass. The net force would be the difference between the buoyant force and the weight. Whether or not an object sinks depends on the magnitude of the weight and the volume of the object. So if it's a heavy object and is small, it will sink. If it's a heavy object but it's really huge, it can float. That's why boats are made of metal, yet they can float. Okay, a couple of things to think about, since this is the last bit of today's lecture, is what is the density of water? That would be a good thing to know coming into the lab. At least look it up so you know. What is the density of mercury? How much more dense is mercury than water? And what are some things that would sink in water but float in mercury? That's kind of fun. You might be able to find a couple of videos on that on YouTube. Anyhow, you guys have a good day, and we'll see you in lab. Bye-bye.